Let us look at binomial expansion. Can be given expand 2 plus 3 divided by x raised to power 5, and hence find the exact value of 9.5 raised to power 5. Yeah, it can be tiresome if you begin to expand this, that you want to expand it to power 5. Sometimes it is very tiresome to expand this 1, 2, 3, 4, this to power 4, then to power 5. So to expand all these one sometimes become tiresome. So we are required to draw a very simple table where we have powers of 2, then we have powers of 3 divided by x, then coefficients, then we have products. Now the powers of 2 will be ascending, will be descending from power 5. You have power 4, power 3, power 2, power 1, power 0. Then powers of 3 over x will be ascending. Okay, the powers of 2 are descending from 5 to 0, while powers of 3 over x are ascending from 0 to 5. Now that is power 0, 3 over x is power 1, 3 over x is power 2, 3 over x is power 3, 3 over x is power 4, 3 over x is power 5. Now the coefficients are from the Pascal triangle. The Pascal triangle is like, here we have 1, then we have 1, 1. Now we begin with 1 and we end with 1. In between here, now you add 1 to 1, you get 2. There we end with 1. Begin with 1. 1 plus 2 is 3. 2 plus 1 is 3. Then we end with 1. We begin with 1 here. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1, 4. And there is 1. 1, 5, 10, 10, 5, 1. Now look at this. This is when the power is 0. So when the power is 1, the power is 2. When the power is 3, when the power is 4, when the power is 5. These are the coefficients when the power is 5. This is Pascal triangle, and it was named after Pascal, a mathematician and a philosopher who lived between 1623 and 1662. So he came up with this idea to help us find the coefficient forming a triangle. Therefore, these are the coefficients. Now, first one there is 1, then 5, 10, 10, 5, 1. Now let us just rub it. Now you are required to find the product. This is how to do it. The product, you multiply the numbers downward like that right here. So any number raised by 0 is 1, so 1 times 1 is 1 times 2 raised to the power 5 is 32. Then here we have 2 raised to the power 4 is 16 by 5 is 80. 3 raised to the power 1 is 3 times 8 is 240 divided by x. Here we have 2 raised to the power 3, which is 8 times 10 is 80. 3 raised to the power 2 is 9. 9 by 8 is 720. This x is also raised to the power 2, which is x squared. Here 2 raised to the power 2 is 4 by 10 is 40. Then 3 raised to the power 3 is 27. Now if you multiply that, you'll find that it is 180. 1080 over x raised to the power 3. Just use a calculator to multiply those things. Here you will get it to be 810 divided by x raised to the power 4. And here this one is 1 times 1 is that. We remain with 3 raised to the power 5, which is 243 over x raised to the power 5. So now our expansion becomes 32 plus 240 over x plus 720 over x squared plus 1080 over x raised to the power 3 plus 810 over x raised to the power 4 plus 243 all over x raised to the power 5. So we have just written this one. Now you add because of this addition. You just add like that. So this is what you are required to do. That is the expansion. Hence we are told to find the value of 9.5 raised to the power 5. Now we will say 2 plus 3 over x should give us 9.5. Now you subtract to both sides. Get 2 over x is equal to 7.5. Now this is over 1. Cross multiply, we get 7.5x is equal to 3. Let go side by 7.5. Then x is equal to 0.4. So where there is x here, you substitute with 0.4. Now you will find we have 32 plus 240 0.4 plus 720 over 0.4 squared. Now where there is x, substitute with 0.4, then plus 1080 divided by 0.4 raised to the power 3 plus 810 over 0.4 raised to the power 4, then plus 243 over 0.4 raised to the power 5. Now this thing can solve just using a calculator. Just solve using a calculator, and you realize that you have 7, 3, 7, 8, and 2 all over 32. So this is the exact expansion. You can easily do that using the Pascal triangle to get the coefficient you expand. So if you just expand manually, you'll find that it is very difficult. But now if you use the table or the Pascal triangle, you will find it to be like that. Thank you so much. And if you want to get more now to solve such like sums, subscribe to my YouTube, and you will get more.